All right, hello everyone. Welcome to a presentation called The Art of Investigating Problems in Software. Before we start, you know the drill. If you have any question, join us at Slido. So let me quickly introduce myself. So I am a lead software engineer at Sabre. I spent there the most of my career. And during my career, I had the opportunity to work with many different technologies and frameworks, and that combined with the tendency to jump right into action, hands-on, resulted in me developing some techniques for investigating any problems in software, regardless of technology or framework, which I would like to share. I quickly found that I grew to love debugging. I found that it's something that makes me learn really quickly. So let this be my first tip for you. Enjoy your debugging sessions. We often tend to get frustrated during long and tiresome debugging sessions, where we seemingly do not make any progress towards the original goal. But let's keep in mind that, after all, we are gaining some value from that. We are, after all, getting the system that we are working with better. We are getting to know the tooling a little bit better. And next time, if we see some similar cases, we will know what to do or not to do. It's really important to have that positive mindset that we are gaining some value from this. So we'll go through a couple of real case scenarios that will prove that debugging can be indeed fun. So let's start with the case number one. Let's suppose that you are assigned to investigate such a problem in an online encyclopedia. So as you can see, basically we have a problem that characters outside of Latin alphabet are being displayed incorrectly. And for the sake of the presentation, let's assume that we have some kind of architecture like this. So the data goes from the front end through a couple of services, and it lands into the database. So if I would ask you, how would you approach this problem? How would you solve this issue? Naturally, probably most of you would apply the following technique. So you would first check if the text is well saved in the front end. After that, you would proceed to check if maybe between front end and gateway service the data gets corrupted, and so on. And at the end, you would see if it's saved correctly in the database. And conversely, in the retrieval process, you would also check that if you didn't find anything in the save process. So this technique, if we would put a name on it, it would be called problem isolation. So it's really important if you are debugging some kind of a complex issue to start with this question, where does this problem happen? Does it happen in your Lambda function, in your ETL process, in your microservices, in your front end? Where does it happen? There are a lot of cases where you can, for example, spend some time to narrow down the problem. For example, you can try substituting a part of a system with another one. And then if the same problem still occurs in the same fashion, then you concluded that the problem doesn't happen in the part which you substituted, which means that you further narrowed down the problem. So it's really important to apply this systematic approach. And another example of the application of this technique is the you need a network OSI model, so which is a standard model for network communications, which you might be familiar with. So if you are investigating any generic problem with your network, like just a lack of network, you would start with the checking the bottommost layer. The physical one, you would check if the cable, the Ethernet cable, is broken or disconnected. If it is not, then you would go up to data link layer to see if perhaps there is a problem with VLAN. If not, then you go up one layer, check the network layer if it's a problem with routing or something like that. And yeah, this is the technique that many network experts use among the globe, which is another example of the problem isolation. So speaking about networking, we'll jump right into the case number 2. One time I had this case with Lerna. Lerna, if you don't know, is a tool, the build system for managing JS monorepo. And I was trying to set it up with conjunction with our company's internal NPM registry. And I tried all of the configurations I found in the documentation, tried everything. Still, I was getting some unauthorized errors. So I decided to take a look at a bit more low level what's going on. And often, those low level tools can rescue us. So in this case, I used Wireshark, and I found that on the network level, nothing happened with authorization. There was nothing there, and actually it turned out to be a problem with a range of versions in Lerna, and based on that, I was able to mitigate that. So speaking about low-level debugging, case number 3, investigating a Maven build issue in a large project. So I was working in a very, very big Java project with more than 500 modules. And basically, we got this issue, duplicate project exception, which basically means that one of the modules is included more than once in the reactor build tree. So, it's fine that Maven tells us what the issue is, but actually the problem is that it doesn't tell us, in what places the project is duplicated. If it did, then we could, directly go ahead and solve the issue. So if Maven doesn't tell us this, then we can actually do it for ourselves. So before we do that, we can formulate the plan of action, which is also a great tip if you are expecting to spend a little bit more time on something, then it's good to formulate the plan. So in this case, the plan would be as follows. So firstly, we would download the Apache Maven source code. Then we would load it up in the IDE of our choice. Later on, we will run the Maven debug command with a particular goal that we are trying to investigate, which will expose a port for remote debugging, which we can then attach to from our IDE and find something that we want to find. So before we do that, I would like to discuss a couple of useful debugger capabilities that can help us in this case. I highlighted the two most important I think will be great for this use case. The first one is exception breakpoint, which you might be tempted to use a kind of alternative like setting up a breakpoint in a catch clause. But the advantage of exception breakpoint is that it allows us to see what's the runtime, all of the runtime context information. So you could see what were the values of variables at the time when the exception was thrown, compared to if you would stop in the catch clause, you would only see, the context inside the catch clause. So it's really useful. And since Maven, even on this message on the bottom, you can see duplicate project exception. So we already knew what exception are we looking for. So we can start with making that exception breakpoint. And another really, really useful capability is drop frame. So I like to call it going back in time, sort of. So if you're not familiar with it, it basically allows you to drop a frame or a couple of frames to go back to the execution of go back in an execution flow. So this is particularly useful in a case where you, for example, stop at the place where you conclude that it's too late. You already missed your opportunity to see something interesting. So what you can do in that case, instead of running the entire program, you can set the breakpoints in a place of interest, drop a frame or a couple of frames, resume the workflow, and this time you would stop in the place that is interesting for you. So if we go ahead and apply those capabilities, then we quickly land at the default project builder class in Maven. And it's amazing. We can see in the debugger window the two conflicting import paths. So if we start with the first one, we can watch the red arrow, and we can see that from the project root, we are including this particular module for the first time, and also we are including in this way. So it's indeed a conflict. So at this point, we found out what we wanted to find out, and it's just a matter of trying to remove one of those module definitions, of course, ensuring that nothing breaks. So lesson learned from this: don't be afraid to dive deep, in the code of external libraries. It looks scary, but in reality, it is not. So that is a really, really valuable technique. So speaking about still low-level debugging, but here is a case where the tool doesn't provide us such useful capability of attaching a remote debugger. So at one point, we were trying to add some security context in Canico container. Canico, if you don't know, is a tool for building Docker images from Docker files in a Kubernetes cluster. And we wanted to drop kill capability, which basically means that the real or effective user ID of a process sending the signal will have to match the real or effective user ID of the process receiving the signal. So in other words, in this container, we won't be able to kill not our own processes. And it was really interesting why Canico needed to do such a thing. So yeah, because it turned out that after adding this drop kill capability, the Canico resulted in an error. So it was really interesting why Canico needed to do such an operation. So in this case, the plan of action would be a little bit different. So we can use strace. Is a really, really big gun for debugging. It's a tool for tracing system calls and signals. So since kill is a signal, we will be able to see what's going on under the hood with strace. So After attaching to the process with strace, it became quite obvious that the case was as follows. So in the Docker file, if you had to run a shell command, let's say run command A, and the command A in return spawned a daemon process B, then this daemon process had a different effective user ID, which basically caused the issue in the first place. So at this point, since it was found out, it was just a matter of mitigating that, and the problem could be solved. And that's it if it comes to the cases that we'll be looking at today. So some key takeaways from this. The first one, okay, so to answer a question, what it takes to be a great, great engineer who can do great debugging. The first one, what it takes is enthusiasm. So just have a positive mindset. It always keep in mind that you are gaining some value from your debugging sessions. And the second one is courage. So don't be afraid to look under the hood. Dig deep into what's going on, even in the code of external libraries, or the usage of seemingly very scary tools like strace. And that's pretty much it. I think we have a few more minutes for Q&A, so let me switch over here. Okay, so the question is how to debug web flux reactive. So unfortunately, sorry, I'm not sure if we can see the screen. Okay, basically the question is how to debug web flux reactive. So I'm afraid I won't be able to give a good answer for this question since I'm not really working in that technology. But I'm sure that I can give some recommendation, but probably it will have to be after some further research. I think that's all we had. So thank you, everyone. If you have any further questions, feel free to approach me. I'll be around on the corridor. And if you have any feedback as well, it's very welcome. So thank you.